Okay, so today we will start with the universal gravitational constant G, right? Now we will be first of all discussing about the SI unit of G. But first of all, we have to find out that how to find out the universal gravitational constant. As you know that from the Newton's universal law of gravity, we have concluded it that the force existing between the gravitational force existing between the two objects is equal to G into m1 into m2 upon r square, where m1 is the mass of one object and m2 is the mass of another object, and they are separated by the distance r. So the force of gravity which exists between the two objects is m1 into m2 upon r square, right? Now, in order to find out the value of this universal gravitational constant G, let me multiply the two. And in order to find out the SI unit of G, let me multiply the cross multiply F into R upon M1 into M2. You know the SI unit of force is Newton. SI unit of R, that is distance, is meter. Here it is square. So here I will also attach the square to it. And kg into kg. Kg into kg, right? Anything raised to power 0 is 1. So I can write it like this, that Newton meter square upon kg square. So SI unit of gravitational universal gravitational constant. SI unit of universal gravitational constant is Newton meter square per kg square. And the value of universal gravitational constant is, the value of this G is equal to 6.67 upon 10 raised to power 11. That's very feeble force, very small force. I can rewrite it like this, 6.67 into 10 raised to power minus 11 Newton meter square upon kg square. So this is the value of G. And let me tell you, the value of G does not change anywhere in the universe, because universal law of gravitation holds good everywhere in this universe. So the value of G, that is equal to 6.67 into 10 raised power minus 11, will be universal. It will not change anywhere in this universe, right? So now if I say that let there be the two objects of mass m1, let its mass be 1 kg, and there be another object M2 whose mass is again 1 kg, and they are separated. They are kept 1 meter apart. They are kept 1 meter apart. Then what will be the force of gravity existing between the two? It will be equal to 6.67 into 10 raised power minus 11. How is it possible? Let me tell you. As we know, G is equal to F into R square upon M1 into M2. Substitute the value of R, substitute the value of M, substitute the value of M2. They are all unit entities. So I can say that G is equal to F into 1 square upon 1 into 1. That is equal to G is equal to F. And we know the value of G is 6.67 into 10 raised power minus 11. So that's why we say that the force of gravity is very feeble. For example, if you are keeping the two objects of 1 kg mass separated by the distance of 1 meter, then the force of gravity which is existing between the two objects will be equal to 6.67 into 10 raised power minus 11. If Therefore, universal gravitational constant is numerically equal to the force of gravity. Universal gravitational constant is numerically equal to force of gravity, that is G is equal to F, that is equal to 6.67 if the two objects are of mass 1 kg and they are separated by the distance of 1 meter, right? So I hope that now this point is quite clear to you. Now we will be discussing about the importance of universal law of gravitation. The universal law of gravitation will explain us all the phenomena, that is why motion of the moon take place around the earth. In the same manner, it will also explain us the motion of planet around the sun, rise and fall of the tide due to attraction between the moon and sun. As I have told you that the universal law of gravitation holds good for every object in this universe. Now, next topic is our Kepler's laws of planetary motion. Kepler's law of planetary motion. What Kepler was let me tell you, Johannes Kepler has proposed three laws for planetary motion. That is motion of the planets around the sun. Motion of the planets around the sun. He proposed three laws for it. And these laws are known as Kepler's law of planetary motion. First law which Kepler has given was that every planet move. The law states that every planet move around the sun in an elliptical orbit with sun at one of the foci of the elliptical orbit. Now, what is an elliptical orbit? Let me tell you. Let me explain it to you that what is an elliptical orbit. You all are aware of the circle. You all are aware of the circle, which is always constructed by having a center, and its radius is always constant. A circle can be constructed with a center where the distance between the center and circumference is called as a radius, and radius of the circle is always constant, right? This is what is a circle. This is what you know about the circle. Now, let me tell you now what is an elliptical ellipse. Ellipse is a geometrical figure which has two centers. Ellipse is an oval shape, what we call. In the layman's language, it will be called as oval shape. Ellipse is a geometrical figure having the two centers, which can be constructed by you having two centers. And the center is not called, it is called as foci, right? Sun at one of the foci. So the geometrical figure which can be constructed with the two centers, that's called as ellipse. And what the Kepler said about the motion of the planet around the sun. He said that the planets are revolving around the sun, but not in a perfect circle. In fact, the planets are revolving around the sun in an elliptical orbit with sun at one of the foci. With sun being at one of the foci, I have told you that it can be constructed by using two centers, and sun at one of the center, or which we call as at one of the foci of the elliptical orbit. All the planets which are revolving around the sun, whether it is Uranus, whether it is Neptune, Jupiter, they are revolving around the sun in an elliptical orbit. Rather than a perfect circle, they are moving around the sun in an elliptical orbit with sun at one of the foci. This is the first law which was given by Kepler. Now, second law was second law. Second law says that this law says that line that connects a planet to the sun sweeps out equal area in equal interval of the time. Line, I once again say that line that connects a planet to the sun, a line which connects planet to the sun sweeps equal area in equal interval of time. The line joining the planet and the sun sweeps equal area in equal interval of the time. Let me tell you what does it mean. It means that planet does not move with the constant. It gives us idea about the speed of the planet. The second law gives us the idea about the speed of the planet because it says that the planet does not move with the constant speed. When it is quite nearby to the sun, it will move faster. When it is away from the sun, it will move slowly. Why? What does it now? How can we say that? Because if sun, if the planet, if the planet would have moved around the sun in a perfect circle, then it would cover equal distance in equal interval of time. Why? Because the distance between the sun and the planet is same everywhere. If I consider that planet is at position A, position B, position C, position D, and sun is here, if it would have been true, sun is here, and if the circle would have been, if the path followed by the planet would have been a perfect circle, then it would have covered equal distance and the speed would have been constant. But here, as first law of Kepler say that the orbit in which the planet moves around the sun is not a perfect circle, it is an ellipse. It's an elliptical orbit. It is an elliptical orbit. It's an ellipse. So it means that the speed of the sun the speed of the planet will not be constant. Why? Because the distance between the sun and planet is not same at every point. Here it's quite nearer and here it's quite far away. At point A, this distance between the sun and the planet is very, very less. And at point B, the distance between the sun and planet is it's very far away. Now, if we talk about the universal law of gravitation, it says that the force of gravity between the two, regarding distance, it says that force of gravity regarding the two objects is inversely proportional to distance. Is inversely proportional to distance. It means that if distance is more, the force of gravity is less. And if distance is less between the two objects, then automatically force of gravity will increase because it is inversely proportional. So we can say that when the distance decreases, the gravitational force here between the sun and the planet increases and the speed also increases. But when it is quite far away, the distance increases. Because of that, the gravitational force between the sun and the planet decreases. Naturally, the speed will also be slow. So that is why we say that when the planet is closer to the sun, it moves faster, sweeping a longer path in a specific time. But when it's quite far away, when it is quite far away, such that area sweeps are equal, right? So I hope that, so it gives us the idea about the speed, that the speed of the sun, speed of the planet moving around the sun is not, it tells us that a planet does not move with the constant speed around the sun. It speed up while approaching. Why? Because the distance between the planet and the sun is less in this position, and the distance between the planet and the sun is quite far away there. So it says that it speed up while approaching the nearest point, and it slows down while approaching the farthest point. Therefore, distance covered on the orbit within the given interval of time at perigee is greater than that as the apogee, such as that area swept are equal. So this was all about the Kepler's second law.